If this was a minus b, then the conjugate would be plus b. So it's always the same thing you see, change the sign in between. All right? And the reason we do it, what's the reason we do it? Because what happens when you take a minus b and multiply it times a plus b? It's conjugate. It's a difference of squares, and what happens is you get this. So what will happen is basically your a is going to get squared and your b is going to get squared. And isn't squaring that going to be nice? Yep. Yes, it'll get rid of the root. So indirectly we squared it, but we had to do it properly by introducing a conjugate. Okay, so numerator, this times this, x plus 9. Okay, what can you tell me about the two next multiplications, this one and this one? They're going to cancel each other out. That's the design of it. That's why we do it. So I'm not even going to write them out. Then the very last multiplication here to here is what? Holy moly, look at that. What's that up there? X plus 5. That's what I needed, right? And it's going to work like this a lot. So on the bottom we had the x plus 5, right? And we're supposed to take that and multiply times this? Don't. Leave it alone. Leave that conjugate over here. Don't touch it, because we want this separated so that we can cancel on the next step. Understand? So look, again, you could qualify this as being a trick, but at the end of the day, it's algebra, isn't it? I mean, there's nothing, we just did something that didn't seem as natural, but now we know when we see roots and limits and we're getting 0 over 0, we now know that you can actually put a conjugate in there and just hope for the best. There's no guarantee it's always going to work, but this is promising, right, that it did this time. All right, so limit, still have not removed the limit. Do you want me to go ahead and cancel this now, or you want me to write it all over? Cancel it. So this right here is x plus 5. That's what this is. And now this factor and this factor cancel. And so you're left with a 1 on top, and on the bottom you have that conjugate thing that was there. And now when you plug in -5, you don't have that same problem you had before. Right? Now do your direct substitution. What would you get? 1/4. Bam. We're good. Okay, I will let you do the rest of those problems. I mean, you have a homework assignment off of that, right? Just double check your homework assignment on that. Okay, I'm going to modify this homework assignment. Get you down to business with this. For 1.4, I want you to do 11 through 27 odds. And then 49 through 53 odds. Now 49 through 53 odds we haven't talked about, so I need to talk a little bit about that now. So far what we've talked about, what we've discussed, is that when you get these limits and you get 0 over 0, you're going to try some algebra in there, right? When you see complex fractions, we put them together and it seemed to work. When we saw the root, we came in with the conjugate and it seemed to work. So you're just going to have to play with these and try different things and then get it to work out. All right, so there are two very special limits that we need to know. Here they are. Know these. I'm going to write them on the board over here so we can refer to them. All right, so let's take a look at the first limit. X approaches 0. So let's try direct substitution on that one. What would you get up on the top? Sine of 0 is 0, right? 0 divided by 0, that's a bad thing, right? So we try some algebra or some trick. The problem is, you don't have any algebra or any trick that's going to get you around this. All right? There's no way we're going to be able to do that. There's nothing I can do that's going to make that turn out to be 1. Right now, you have to just take on faith that that's 1. That if you draw this graph, if you graph it, it'll actually go to 1. I showed it to you already in one of the other, in the lecture video. You probably didn't realize you were looking at it, but I'll put sine x over x. Oops. Sine x over x. What the heck is going on? I forgot I was typing in Mathematica. What the world? Oh, capital. I keep on forgetting that I'm not like on Wolfram Alpha right now. There we go. There's the graph. There's the graph of sine x over x. And you can see that as you approach 0, where is it headed? 1. It's headed to 1. But there's no way to show it algebraically. It's not possible for us to do it with what we've been doing so far. There is a way to show it, though. It's a very, very elegant proof that somebody worked on for a long time to get it to work out. I don't have the time in this class to do it. It'd take about 45 minutes to do. So I'm not going to do it. And then later on, we get something called L'Hopital's rule. And once we have L'Hopital's rule, this problem's very easy. Very easy. Okay, so right now, we're just going to all just store in our memory banks that anytime we see this, it's 1. Right? It's 1. The graph is confirmation of that. But I also want you to look at this a different way. Okay? This is the formula, but I want you to almost look at this formula like this. Let's say you're taking a limit. You got the variable x, and it's headed somewhere. And it doesn't matter. It's headed to 2, it's headed to 0, it's headed to 5, it's headed to something, right? And up on top, you have sine. And inside of sine, you have what I'll call junk. You've got some junk in there, right? Whatever it is. In this case, the junk is what? X. But it could be anything. And in the denominator, you have the exact same junk, right? The answer to this will be 1. As long as this. These junks have to match exactly. Exactly have to be the same. And the junk must be headed to 0. So when I take the limit, this might be doing something here. I've got these two things match exactly, and then when I do the limit, that goes to 0 and that goes to 0. If that happens, the answer is 1. I'm going to give you an illustration of this in the next example I'm going to do right now. Also, if you flip this over, flip that over, you get the same thing. So if you do the limit backwards, you put the x on top and the sine x down here. You don't need parentheses. This is still 1. Works both ways. All right, so with that, let me just do this quick example. What is the limit as x approaches 2 of sine x minus 2 over x squared minus 4. So what's the first thing you do when it comes to direct substitution? Okay, so hold on, I'm getting a battery warning on this microphone. What's that?
Maybe 0.
You do have 0 up here and 0 down here, right?
Yeah.
So the direct substitution is giving you 0 over 0.
Would be sine
Right.
0 over 0?
It's sine of 0 over 0, but sine of 0 is 0, right? So that's why we're getting 0 over 0. We'll just do it. Okay, so here we did have that this goes to 0 and this goes to 0, right? But they didn't match exactly, did they?
No.
So you couldn't say that this was 1 up here. You had to get these two to match. And fortunately for us, the denominator's factored. The denominator factors the difference of squares. So what I'm going to do is I'm going to say this is equal to, we know that this piece right here, the whole thing, turns into a 1, right? And then we know that this would turn into what? Replace it to, so 1 times 1/4, which is 1/4. So we get 1/4. Questions? Now I'll give you one that's really tricky. This is like a classic problem right here, this one. Students seem to always not like it. The thing that's difficult with the calculus class is that there's so many little things in the algebra that I want to show you to help you be able to do good on your homework and be able to do good on tests. There's so many little things. It's very difficult for us to, say, stop class and let's do some group work and let's work, here's a couple of examples you work on. I'd love to do that. But I mean, it's already, I'm still only, 25 minutes is all I have left? And I mean, we've got a lot to do still. So just keep in mind, it's not that I don't want to get you to work in groups, I don't have time for it. So I encourage you to, try outside of class to form groups and get together and study. Don't wait till like the week before the test. Try and form some groups now. Get together and do your homework. All right, so here's one. I said, this is like a classic problem. Boy, okay, I'm just trying to decide how bad I want this to be. We'll go mild. This is mild.
Can you?
Direct substitute first,
Oh, okay.
right? Always start with direct substitution. What happens if I just directly substitute and replace all my thetas with zeros? You get tangent of 0 over sine of 0, right? Tangent of 0 is 0, sine of 0 is 0, so you get 0 over 0, which means that you need to do some work. See, I can come in here, I can show you 40 examples in one day, but you'll get a homework problem that I haven't shown you. And you've got to be able to take the bat to it, you know? You just got to be able to keep beating the problem up until, I mean, either you're going to quit or you're going to beat the problem. One of those things has to happen. So it's part of this whole calculus sequence is how easily are you defeated? Are you going to be relentless against this, or are you just going to be like, I just have no idea, this is too hard. You know, it's too much algebra. Or are you actually going to enjoy the challenge of it and try and get past it? Because it's all just algebra in here. Just crazy algebra. Okay, now what? This one's not as natural. Don't be going and killing the thetas off, right? I mean, that's where, even when you're sent to math hell, they still beat you, because it's like, no, that's like the worst thing you could ever do. Yes?
Can you put tangent sine over cosine?
Okay, so tangent is sine over cosine. So you're thinking just turn that into sine over cosine?
Yeah, and multiply over reciprocal.
Okay, so how about sine 3 theta over cosine 3 theta?
Yeah.
And then what do you want me to do with the sine 5 theta?
Multiply by the reciprocal, so flip it over, put over 1, and then flip it over.
Well,
Can you do
it
that?
would still wind up the same place it is.
Oh, okay.
It would wind up down here with this.
Yeah.
Yeah, you could do that. I mean, however you want to look. I'm just going to do it a little different.
Okay.
I'm going to take this sine 5 theta, I'm just going to move it to the side and then create the fraction. And how about it would look like this? Right, that's the same exact thing?
Yeah.
So I just took this sine 5 theta, moved it out to the side as 1 over sine 5 theta, and turned my tangent into this. I agree that's correct.
Then you get comment on there?
Well, it's multiplication, so I don't need to. I don't need to add. Where's the problem occurring? Where do we have an issue?
There's no cancellation.
We don't have cancellation, but what's causing me to even have to worry about any of this? Like, what's even creating the problem for me? The division by 0, right? And that's occurring with this one, isn't it?
Yeah.
That's the one that's really messing everything up. What's cosine of 0?
1.
1. What's sine of 0? 0. 0 over 1 is
6.
0. So 0 is fine, but 1 over 0 is not fine. So I need to somehow make that sine 5 theta not create this huge pain in my side, right? Okay, so here's the magic. Let's see the trick. Okay, here's the trick. I'm going to be very clever. What I'm going to do is I'm going to try and just watch me first. I'm going to try and put a 5 theta here, because if that were a 5 theta, what would happen?
It can be 1.
This would become a 1, because you would have the junk matching, right? Exactly. They both would be going to 0 when theta goes to 0. So both those are going to 0. They both match. It's flipped over, but I said it could be done both ways. So that would go to 1, wouldn't it?
Yeah.
But I can't just arbitrarily walk in and just throw a 5 theta up there. That can't possibly be allowed, right? But what I could do is this. I can multiply by 5 theta over 5 theta, and then using multiplication properties, just slide that 5 theta on top, couldn't I? I'm allowed to do that. Do you agree I'm allowed to do that?
Yes.
Okay. Now let's see if that actually gets me anywhere here. I still have sine 3 theta over cosine 3 theta. I now created 5 theta over sine 5 theta, but what do I still have over here?
5 theta.
1 over 5 theta, right? So have I fixed the problem?
No.
What does this one go to again?
0.
That goes 0. 0 over 1, that's fine. What does this one go to now? 1, that's fine. But what does that go to?
0.
1 over 0. That's undefined. So I fixed a problem, created a new one. Didn't I?
Mm-hmm.
It's like plugging a leak in a boat, and then another one pops up, and then you plug that, and another one pops up. It's kind of what's happening here. But there's still something I can do. That sine 3 theta up here, I'm going to kind of use it against itself right now. Okay, watch. I'm going to go one more step in peeling this apart. I'm going to take this sine 3 theta over cosine 3 theta, and I'm going to write it like this, because this is exactly the same thing. All I did there was just peeled this apart into 2 different factors. And why would I do that? If this is now the thing that's causing me a problem, why would I try and focus your attention on this?
Should we just multiply the numerators together and the denominators together?
Well, this is not a problem, right? This is 1 over 1. That's not a problem. This one I know is going to go to 1. This one actually is not a problem either, right? This is 0. This is the problem. But I'm trying to get you to see that there's something I can do with those two.
You can multiply these.
How do you mean?
And they sine 3 theta times, no, never mind.
Just move the 5 theta into the denominator.
Okay, it's multiplication, right? So I can multiply, I can move this in front, I can move this over here. I can move it all the way underneath the sine 3 theta, can't I? So I would have a 5 theta under here,
Yeah.
but I don't want quite 5 theta because I need these to match, right? So why not bring the 5? Leave the 5 over there. Just bring the theta over here. And then what are you missing?
3.
A 3. Can you introduce a 3?
Yeah.
I could throw a 3 in here, but whatever I do on the bottom, I have to do on the top. So I'm getting extremely clever now, and I'm realizing all of this at one time. I'm saying, look, I'm going to use that theta under that sign, but I need a 3 to be there and not a 5. So I'm going to come in here right here next to this, and I'm going to multiply the top and bottom by 3. That's going to create my 3 theta that I'm going to need when I slide it over. See, right? I mean, this is not just, I mean, calculus is a different animal, right? I mean, this is just a totally different animal than it is most of the other math courses, because you're having to really kind of think a different way, I guess, right? What am I going to put under there now?
3 theta.
That 3 and that theta, right? So there's my 3 theta. 1 over cosine 3 theta. My 5 theta over my sine 5 theta. And then tell me what's still over here, because there's still stuff here. Not all of it's gone.
3 over 1 and 1 over 3.
Is this 3 up here still?
Yeah.
Mhm.
Yes, that never got moved anywhere. Is this 5 still here?
No, it's 4, right? Because you took 1.
No, because it's multiplication.
All right, yeah.
I took the entire factor theta out. I didn't like reduce it by 1. So that theta got slid away. I still have the 5 down there, right? The theta's gone, and the 3's gone. So that's all I have, right?
So that's the
3/5. Well, now I have to take the limit. But all of these should be okay.
That's 1 though.
This is now 1, right? When I take the limit down, notice I'm going to have no more limit symbol because I'm taking the limit. This right here goes to 1 because of the formula I told you about. This goes to
1.
1 over 1. This goes to 1, and then 3/5. And the answer then is 3/5. So I'm recording this. You go back and watch it if you've forgotten when you're doing your homework. But remember, this is just one example of using this. You just now need to know that you can always try and manipulate these to make them look like you need them to look. And as holes spring up, you try and plug them and you try and figure out where to fix things and slide things around. I've always felt like this type of problem is a good gauge of where my students are, if they can handle something like that. I think that's probably... This formula I haven't used, right? That's another formula. That should be equal to 0. That was the other formula you should know. The thing about that one is you can do the same thing. You can replace that with junk and junk, replace the x's with junk, and that would go to 0. The difference is you can't flip that one over. Okay, you can't reciprocate that one. And the reason is because it's 0. The answer is 0. So if you try and flip it over, it's 1 over 0, and that's undefined. So, but you could have trig stuff. Let me see if I can make one up real quick. Just think of one. Here we go. How about this? How about sine theta cosine theta minus sine theta over theta squared? So what's the limit as theta goes to 0? What do you get here?
Sine theta, cosine theta, 1.
Yes, it's multiplication right there. What do we get if we try direct substitution?
0, 0.
Direct is going to be
Squared.
Yeah.
0 over 0? Yeah, it's theta squared. I always have trouble closing off my theta, sorry. So we need some algebra. Anybody see what we can do?
You can take the signs out. Factor the
You
sign.
can factor a sign out of the numerator. Good. Sine theta. You're left with cosine theta minus 1 over theta squared, right? Okay.
The identity is cosine squared, right? Minus 1.
Yes.
That's the
Yeah,
identity,
so we
not
can't,
that.
yeah, we can't get to it that way. It's good though that you're thinking that way, but I don't think I can get to it that way.
Split them, so then you have a sine theta over theta and cosine theta.
Yeah, you split it. Split it. Look, you've got 2 factors of theta. You got 2 of them to work with. That's really like theta times theta. And this is multiplication here also. So you could rewrite this as limit theta goes to 0, sine theta over theta times cosine theta minus 1 over theta. And now, I mean, now that I've done that, it's almost obvious, right? It's both of these formulas side by side,
Yeah.
right? So the first one goes to what?
1.
1, and the second one goes to 0, so your answer is 0. But you can't tell that from this. You can't tell that from this. All right. So you've got your homework assignment, but I still have 10 minutes. So we are a little bit behind. I think it was because that first day we were watching too many movies, right? Didn't we watch those movies on? So let's see, what I'm going to do here, we didn't sign in last time, right? So I want you on Monday, the 31st, just initial. Pass this around. This is the attendance for today. I realize I gave a quiz today, so I could take it off of that, but I'm also going to have it written down. All right, so we what you're going to do for next time, you have the homework assignment, right, that I've modified? What do you think about the watching of the videos? I mean, you got to tell me, the course videos that I've asked you to watch beforehand, is it tolerable?
Yeah.
Okay? Okay, I want you to get prepped for the next section, which is 1.6. We're skipping 1.5, we're going to come back to, so we're just going to change the order. I want you to do the course video for 1.6, then 1.5. All right? They're not real long. And that way I can get in here on Wednesday and get right to doing some problems out of those sections. That we get some of the theory out of the way. We have class Wednesday. We're off next Monday. The following Wednesday we have class, and then we have a test the following Monday. So we only have really, what, 2 more class meetings and then your first test. And it's going to be pretty much limits. Most of the test is going to be limits. So I had to plan it that way. It's a little early for me to be giving a test, but I've got a commitment that day. And so I'm going to give the test that day. I'm going to have a proctor come in and give the test. So just heads up, it's going to come quick. So if we don't quite cover the material to get us to that point, I'll just trim the test down. Yes?
Do you have a study guide online for the first test or no?
I have study guides for a bunch of old stuff, but you can't trust that as being your stuff because they cover a different amount of material. Their test, might have been further along. Just wait for next week or one after for me to give you more indication of where, what we're going to be studying or what we're going to be tested on. Okay, so if you are going to tell me you're going to do this, right? If you tell me you're going to do that, then I'm going to let you go, but I'm going to give everyone an opportunity that wants to improve their quiz score. If your quiz today wasn't good, I'm going to give you one more shot at it, but it's going to be a little more challenging. So you are free to go if you're happy with your quiz. If you aren't happy with your quiz, take out a sheet of paper.
Everybody's
I messed up on a couple of them.
me too. I made a stupid mistake.
We're doing version 2.0 on the quiz, okay? So look, what I'm going to do is, some of you already know whether or not you got this right or wrong, right? Because I went over it. You're going to have to come up here and you're going to, if you are going to turn in the one that you're going to do right now, you're going to take your other one and say goodbye. Because I'm only grading one. I'm not going to grade them both and take your best one, okay? So if you know you got this one right, I would just call it a day. But here's the quiz anyway.
74?
What's that?
1974?
74. Today's my birthday.
Today's your birthday?
Today's my birthday. Yeah.
Happy birthday.
So I actually wrote my birthday on the board. Hold on. What the hell is it? 15. Okay. What year is it today? All right. So let me see. You like the limits?
Yeah.
You want to try a limit?
Yeah, sure.
All right, let's do a limit. I'll keep you away from the trig stuff for now. Let's just do an algebraic limit. Limit x approaches 3. Try and stick within. You're going to run out of time if I don't hurry up. Okay. Square root of x minus square root of 3 over x squared minus 9. Ooh. Okay, I won't do that to you. I won't do that to you. I won't do that.
Okay.
Sorry. It's a little much, I think. You don't have time for that. That's the problem. You don't have time for that. Okay, see what you can do. 70. What did I write? That's just the homework assignment and stuff.